So far, our application is pretty simple because there's only one layer of hierarchy of our components. We just have our parent app.tsx, which passes down the die state only a single level. However, imagine we had a component within a component, within a component, within a component all the way down. And we wanted something way, way down here to be able to access that same state that we have all the way at the top. With what we've learned so far, our only really approach would be to keep on passing it down as a prop. So from this die input, we'd have to pass it down. And then from this other component, we'd have to pass it down again, and again, and again, and you get the idea. With our example, it's not super immediate what type of situation you would have where your input would have a component on a component on a component on a component. But once you start building complicated websites that have many nested layers of layouts and components within components, this becomes extremely common. And fortunately, React provides us a better way to handle this called context. Imagine that instead of having to explicitly define what state we're going to pass down and pass down and pass down and pass down and pass down, what if instead our bottom component could go all the way back up top and grab just the state it needs? React allows us to do this with an idea called context. A better way to think about our component structure isn't as if we have some hierarchical thing that is passing information down into each child. A better way to think about it is that your top level component wraps all of the children and puts them into one sort of consistent namespace, one consistent context through which it exists separate from the rest of the application that might exist, somewhere over here. And when you look at our code, you can see that our app is literally wrapping our die input, our die display, and our roll result. Earlier, we already showed an instance where we had to take the state that was getting stored locally in the die input, and we had to raise it up higher up in our tree, in our sort of tree of components, so that it could then get used in other components that were at its same level of hierarchy. Context is the idea of wrapping either the entirety or a large percentage of your application such that your data gets put all the way at the top of your app, and then any component that is wrapped by it can access it. So imagine we had a big circle which wrapped the entire app and stored some data and functions in context. Then because it wraps all of these child components, each child can go grab exactly the pieces that they want. So for instance, our die input doesn't actually need the data, it just needs a function to add to that data. So we could just define some function, I need my little pencil, just define some function that goes into the die input. The roll result doesn't have to have any functional requirements, but it needs to be able to subscribe to certain pieces of data. So roll result could specify, hey, I just want some data from the context. But then later, if I want to add some more functionality to roll result such that it needs a greater slice of this context that we define, it can simply declare it and grab it the same way it's grabbing the existing data without us having to specify a prop that gets passed to app and then gets passed to roll result. To get started with context, first create a new folder and call it hooks. The reason being that when we create the context, we also need to create a specific hook which allows us to subscribe to individual items within the context. That is sort of the same as how useState works. useState is called a React hook, and it provides us a piece of state, a piece of data, and a function to alter that data. And then anything that uses it, you can think of it as subscribing to that state. So we're going to create a hook, and it's going to have the context and the hook to subscribe to or hook into that context. So we'll create a new file and we can just call it usedice.tsx. The convention with all React hooks, useState and all the other ones that we will encounter, and the one that we're going to create right now, is you prefix it with use and then say what you're doing. To start, we need to define the type of what is the data we want to store in context. If we look back at our app.tsx, we have two pieces of state, which it probably makes sense for us to move up into context. So we can import those two types, import type die, and also type die result. And then we can create a type for this context. So we can say type die context. We'll have our dice, which will be a die array, and our results, which, if we look back at our app.tsx, is going to be that two-dimensional die result array, like so. So that is the type of our context. Then we need to actually create a context of this specific type. To do that, we can import the create context function from React. And while we're at it, there's a couple other things we're going to need. We're going to need to have the use context hook and the useState hook. But for now, all we need to do is say const dice context equals create context, and it's going to be of that die context type, like so. The only issue is that we normally don't initialize the context right here. So what we're going to do is say it can be either the die context or undefined, and we're going to set it initially to just be undefined. So now we've created this context. Now we need to create the wrapper component that's going to wrap our application and allow us to use the context. It's going to be what is called a provider for the context. So let's do this. Let's say export const die provider, or we'll say dice provider, which is going to wrap the rest of our application and provide it with the necessary context. For now, we can just say that it's going to return a dice context dot provider, and then the value for now of the context can just be undefined, like so. So this value is the value we're going to pass in to the context initially, and then we're going to wrap the rest of our application inside here. But how can we do this? How can we have this application wrap another, or how can we have this provider wrap another component? The way we can do it is with a special React prop called the children prop, which essentially is just going to render inside of the provider. To properly declare that, we can say that we're going to take it as a prop. And to make sure that it is going to be the correct type, we can say that children is going to be a React dot React DOM, or sorry, no, it's actually going to be a React dot React node, like so. So what this means is that this children is going to be some React component. In this case, it'll be our app component, which eventually we will put in here. And then the Dice context provider will live on the outside and completely wrap that entire application. But we don't want the value of our context to be undefined. We want to actually hold some state in here. So what we can do is we can copy and paste this state from our app.tsx, declare it within our provider, since this is a React component, and then pass it down in the context. We can say dice are going to be our dice, and our results are going to be the results. Finally, last thing we need to do before we can start using this is we need to create a hook to actually access this context. So far, we've created the provider, which is going to hold the context. Now we need to create a hook to be able to access it. So as I mentioned, the convention with React hooks is to say use as the prefix. So we can say const use dice is going to be a function which is going to return something. We can actually create the context, or sorry, we can use the context within this use dice hook. So we can say const context equals use context, and that's going to take some context. So in this case, our die context. And then we are just going to return the context, like so. There's some more things we need to do, but this is the base bare minimum that we can do to actually hold our state and then store it. So let's give this dice an initial die. So we'll say an initial test with size 6 and see if we can use this context. First is we need to wrap our app with this context. So let's go to main.tsx, which wraps the app. We can import our dice context, or sorry, the dice provider, and then wrap the dice provider around the app. As you can see, if we don't pass anything, it's going to give us an error and say that it expects some child properties that it's going to wrap. And if we make it wrap the app, then we are all good. Then within the app, we can import use dice from the hook, and we can subscribe to some piece of this context. So we can say const, we'll just say const dice equals use dice. And as we can see, it is going to be of the type die context. Then if we go back to our use dice and properly type this context by saying it's going to be of type die context, go back to app.tsx, we can destructure the either dice or the results from our use dice hook. So let's just get the dice for now and call it context dice. And then if we were to go down and we could just json.stringify the context dice, then we can refresh and see that we are using this data from the context. It's defined in main.tsx. We have the provider, which initializes our dice value and makes it accessible to all components that it wraps. Then the app.tsx uses our custom use dice hook to hook into that context, take out a piece of it that it specifically says it wants to use. And if we wanted to change this and also include the results and say this is context results, we don't have to change anything with the props because our app is already wrapped with the context. A couple other things, we have a type error here because this hook is supposed to return the die context. This context could technically be undefined. This is because we want to make sure that we throw an error if we accidentally try and hook into the context in a component that isn't wrapped by the context. Going back to our example, if we had some component out here that existed outside of our wrapped context and it tried to hook into some of this value, we would want to throw an error because it has to exist within the context to use the context. So all we can do is do a quick check, say if context equals undefined, then we can throw a new error and just say must use dice within a dice provider. And then we don't get the type error because this is guaranteed to be defined. So there you go. That is an example of using context. Now we can go through and see how this can tangibly make our app a little bit easier to use. First off is we don't have to have all of this complex state logic inside of our app.tsx file. And if there's any of it that we might want to pass down, we can just store this in context and have it all defined in one place. So I will put these side by side. We can copy and paste handle delete into here. And it's going to use our same setDice function. We can copy and paste handle roll and even handle clear. I'm going to go one step further and also take our die input function and create a specific function for handle adding the dice. So we can say const handle add. Hopefully it doesn't block me too much. And copy and paste this logic right here, like so. Then we can simplify this a little bit. Our handle add is going to have to take a new die, and we can just set dice to be previous dice and then that new die, like so. So now we have all of our state handling logic and all of our setter functions in one context. And further, we don't even have to expose the direct set results and the direct set dice to anything except this internal context file. This means that if somebody keeps on creating more and more components and you have certain expectations about what dice and results can be, you can specifically only expose the ways in which you want this state to be allowed to be mutated. You can say, hey, I'm only going to let you delete a single thing at a time, or I'm only going to let you handle rolls in this specific way. It provides a nice interface which allows somebody who is using this context to understand what actions are allowed and not allowed. So then if we want to expose these other functions to our context, we can update this type. So handle delete is going to be a function that takes in an index as a number, and it's not going to return anything, so we're just going to say it's a void. Handle roll is not going to take anything in and just be a void. Handle clear is going to be the same. Handle clear. And then handle add is going to take die. So handle add is going to take a, well, it's going to be a void function, and then it's going to take a die. Now, as you can see, it's complaining that we're not passing everything in. So we can just pass in handle add, handle clear, handle delete, and handle roll, like so. And now all of these functions exist as part of our context. So let's do some refactoring and use only this context and get rid of our locally stored state. So here we can delete these useState calls. Make sure this is just named dice and results for consistency. We don't need any of this state handling logic locally. And we can instead use the individual functions that we want. So we can say handle clear, and then that will be defined. Get rid of that. And then handle roll is going to be there. Handle roll. Oops. And handle delete. Handle delete, like so. And now here is the key benefit of context. Since our die input is within the app and the app is within our context, we can completely get rid of this set dice prop. So we can go in, completely get rid of it, and instead just import our use dice context. And instead of handling the state logic here, we can just say const handle add equals use dice, and just call handle add and pass in for our die sides. We can have the sides input. What is it? Number input. Should really rename that. And for the name, it will be the name input, like so. So after we went through that work to define that, dice array, yeah, so we can actually completely get rid of all of these props. The input now no longer needs to take any props. Look at all this code we're able to delete. And we don't have to pass any of that in, like so. So that was a lot, but let's circle back and make sure that everything still works the way we expect. Let's try to add some dice. We can do that. Accidentally added some dice with empty string names. So say die2, add die, and then we can roll, handle rolls, and everything works exactly the same as we had before. However, using this context means that we didn't have to worry about passing props. Yeah, even in the die display, we don't need to pass handle delete. Can get rid of this, get rid of this. And then within the die display, we can get rid of handle delete, import use dice, and get our handle delete equals use dice, and get rid of that. And there we go. Yeah, beautiful. We don't even need the dice here because we can just get the dice from context and completely eliminate that prop. So circling back, now The only thing that needs any props is just our roll result display, and that's because we need to pass in what specific result we're displaying. However, you can imagine that if we had a component that rendered all the results instead of one that just rendered an individual round, then we wouldn't have to pass in the results array. We could instead just take it from context.